Hello, I'm Kirk Weiler, and this is Common Core Algebra 2 by eMath Instruction. Today, we're starting a brand new unit. We're going to be doing Unit 6, Lesson number 1 on Quadratic Function Review. Unit 6 is all about quadratics, primarily parabolas, but we're going to see a few circles towards the end. And even though you extensively covered quadratic functions in Common Core Algebra 1, we want to make sure that in this unit you see both the basics of quadratic functions, including their graphs, parabolas, and that you also see their algebra, including extensive work with factoring and the zero product law. But in this lesson, we're just going to review some basics about quadratic functions. So let's begin. All right. First off, what's a quadratic function? It's any function that can be put into this form, ax squared plus bx plus c, where the coefficient on the x squared term isn't 0. All right, now that's important because b and c can certainly be 0. In other words, you can certainly have y equals x squared, that's a quadratic. Y equals 5x squared, certainly a quadratic. You could certainly have y equals, let's say, negative 2x squared minus 3x, that's fine. But what you can't have is a being 0, because if a is 0, if you had something like this, right, no x squared term, well, then it's no longer a quadratic, but it's a linear function, the equation of a line, right? So it's the inclusion of the x squared that takes it up a notch and gives us what's known as a quadratic function. All right, let's play around with these things. Exercise number 1. Without the use of your calculator, evaluate each of the following quadratic functions for the specified input values. Recall that, according to the formal order of operations, exponent evaluation should always come first. All right. How about this? How about you take this as a moment to make sure that you understand your order of operations and how to interpret things. Pause the video and be especially careful in letter C, but don't use your calculator. All right, go ahead. Okay. Well, let's take a look at letter A. It's very, very simple. F of negative 3, what's our rule say? It says take our input and square it. Negative 3 squared is positive 9, right? This one, it's almost not even worth writing down. 5 squared is 25. Now, when we have g of x, it's a little bit more complicated. If we're looking for g of 2, right, then we absolutely must square this 2 first, which gives us 4. Right? And then we'll do 2 times 4, which is 8, minus 5 gives me 3. Right? Likewise, this one, I'm going to put that negative 1 in first. I'm going to square it. I'm going to get 1, positive 1. Whenever we square a number, it's a positive unless it's 0. And then we just get 0. Here we'll get negative 3. Okay? Now, this one is the hardest. Okay, and it's the hardest because a lot of students will do the following. They'll go, oh, I'm supposed to take negative x, so they'll take negative 2, and they'll negate it, and they'll get 2, and then they'll square it. Well, no, that's wrong. The way we have to interpret this is very similar to how we interpreted letter B, okay? Meaning that I really want to look at this as negative 1 x squared plus 4x. In which case what I have is I've got negative 1 times negative 2 squared plus 4 times negative 2. In which case I square that negative 2 first, I get positive 4, but then I'm still going to have to multiply. I'm going to do that multiplication right away. 4 times negative 2 is negative 8, but then I'm going to still have to multiply by the negative 1. So I get negative 4 minus 8, which is negative 12. If you got that negative 12, then you're doing well in terms of the way that you interpret this formula and order of operations. Let me do this one as well. Negative 1 times 3 squared plus 4 times 3. Again, negative 1 times 9 plus 12 gives me negative 9 plus 12 gives me a positive 3. Apparently, I like the number 3 a lot in this exercise. All right, so just a little order of operations, making sure that we're ready for quadratic functions and all they bring. Pause the video now and write down anything you need to. All right, let's get rid of it. And let's move on. Okay, exercise 2. Consider the simplest of all quadratic functions, y equals x squared. Letter A says create a table of values to plot this function over the domain interval -3 to 3. All right, so go for it. Plot this. Okay, let's do it. I'm not going to use a calculator at all, right? I'm going to do -3 squared, I'm going to get 9. -2 squared, I'm going to get 4. -1 squared, 1. 0 squared, 0. 1, 4, and 9. It says sketch a graph of this function on the grid to the right. Great, so I'll do -3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'll do -2, 1, 2, 3, 4. -1, 1. 0, 0. 1, 1. 2, 2, and 3, 9. And now for the Euler guarantee of a badly drawn graph. Oh, man. Now, little comment on arrows, okay? It's very understandable when students put arrows on this because the parabola does continue to go up forever. On the other hand, right, it says create a table of values to plot the function over this domain interval. So if it's just this domain interval and only this domain interval, then that's all we should do and we shouldn't extend any arrows. Okay? No arrows on this. No arrows. So we've sketched the graph. Now it says state the coordinates of the turning point. What are the coordinates of the turning point? You should be able to write those down. All right, the turning point, also known as the vertex of the parabola, is probably the most important and identifiable point on the parabola. On the simplest of all parabolas, it's at the point 0, 0, the origin. All right. Now it says state the equation for this parabola's axis of symmetry. The axis of symmetry is a vertical line. I'm going to draw it in, I think I'll draw it in blue, a vertical line that cuts the parabola into symmetric portions. So its axis of symmetry is that blue line. And since it's a vertical line, it has the equation x equals a number. Remember how vertical lines have equations like x equals 4, x equals -2, etc. And specifically, this one has the equation x equals 0. Finally, it asks us over what interval is this function increasing? Now, the way I want to think about that is if I'm walking from left to right, always left to right, for what x values is the function going uphill? And there's really two acceptable answers here. We could say, well, it's for all values of x that are greater than 0, but less than or equal to 3 in our problem. Or we could say that we include the 0. Either one of these answers is completely okay. All right. There seems to be a lot of confusion these days about whether or not, with intervals of increase or decrease, whether you should include the endpoints like 0. Specifically, should you include turning points? And the official take on it is that there's no official take on it. That you can really do it either way. Include the turning points, don't include the turning points. It won't matter from an assessment perspective, right? And to me, I like it both ways. You know, do you include the top and the bottom of the hill, or do you exclude the top and the bottom, right? I don't think it matters. Okay, pause the video now and write down anything you need to. All right, let's clear out the text and keep working. Exercise 3. Now we're going to get into our calculator tables a bit. Consider the quadratic function f of x equals -x squared plus 6x plus 5. And the first thing it asks us to do is to use a table in our graphing calculator to try to figure out the turning point of this function. Let's see how to do that. All right, I'm going to bring out the TI-84 Plus. Now there's not a lot of room on this screen, and I apologize because I'm going to have to enlarge the calculator, shrink it, move it, put it all over the place. My head's going to get in the way. It's going to be pure chaos. Cats hanging out with dogs, things like that. Anyway, so let's put that formula into y equals. Let's hit the y equals button. Let's clear out any equations you might have in there. All right, and now let's put in -x squared plus 6x plus 5. As always, make sure that negative is the negative sign and not the subtraction sign. It'll give you an error if you put subtraction there, but then you might not know what the error is. Make sure your formula looks good. And then let's hop into the table. Now, what should we begin our table at? Well, that's a great question because I don't know what the turning point is. That's the point, right? I don't know where to look, things like that. But I will say that the problem has supplied me with graph paper. And the minimum x value on that graph paper is -6. So that's where I'm going to start my table, is at -6. And I'm going to make my table go by ones. So let's set that up. All right, and let's now pop into the table. Okay. Now I'm going to bring my cursor over to the sort of y column, and I'm going to start hitting the down arrow. All right. And what I notice is that those y values are getting larger. They're going up. Yeah, they're very negative, but they're definitely going up, right? They're getting closer to 0. Now, if I keep hitting the down button, eventually they become positive, right? And see, keep hitting them. Look at that, right? It's getting up to 10 and 13 and 14. And then it goes back down to 13. Did you see how it changed direction and now it's starting to go down again? And also notice that symmetry. At x equals 2, right? At 2, we have a y value of 13. At 3, we have a y value of 14. And at 4, we have a y value of 13 again. So that's how you can spot the turning point in a table. So the turning point has coordinates of 3, 14. It's going to be, somewhere out here. All right. Letter B. What is the range of this quadratic? The range. The outputs or y values. Well, all parabolas either look like this, and they have a range of y less than or equal to something, or they look like this, and then they have a range y greater than or equal to something, right? This parabola looks like this one because it has a leading coefficient that's negative. And I mean, we can even see that in the tables. That means it has a maximum y value, a max y value. And that maximum y value is right there. So our range is going to be y less than or equal to 14. You can also put it in interval notation if you like that stuff, and it would look like that. I think I'm going to stick with y is less than or equal to 14. Okay, now it says graph this function of the grid to the right. Probably should say graph this function on the grid to the right. That sounds a little bit better. So let's take a look at that table. I'm going to just start to plot points. Now, if I go up in the table until I hit sort of what I think will be the first point that lies up on there, that's going to be the point -1, 2, right? So -1, comma -2, sorry, not 2, comma -2 is going to be right here. Then 0, 1, 2, 3, 4, 5. Then we have 1, 6, 7, 8, 9, 10. 2, 11, 12, 13. 3, 14, 4, back down to 13, 5 is at that 10 mark, 6 is back to the 5 mark, look at all the beautiful symmetry, and 7 is back there at -2. All right, again, come on. And this time I am going to put arrows on because they didn't say to graph it over a particular domain. They just said graph the function. So there it is. Not beautifully graphed, but there it is. Trust me, I would do a much better job if I was drawing on a piece of paper, but I'm drawing on a graphics tablet that's off to my side while trying to control my hand by looking at a screen. It doesn't do well. It never does well. But there it is, right? Now we've kind of answered letter D, but let's make sure that we have it. Why does this parabola open downward? This is a downward opening parabola versus y equals x squared, which we saw before, that opened upward. Why is that? Think about it. Write something down. Pause the video. Now, what a lot of people will write down, and this is not a great answer. They're getting the idea right, but the answer is not great. Is a lot of students will say, this opens downward because the x that's being squared is negative. That's not what you want to say. You know, what this formula really is it's really negative 1 times x squared plus 6x plus 5. So it's all about that negative 1. And the correct answer, with proper terminology, is the leading coefficient. The leading coefficient is negative. On y equals x squared, the leading coefficient, the first coefficient, is positive. It's a positive 1. Okay? Don't say that the x squared is negative. X squared can never be negative. Whenever you square a number, you get something that's positive or 0. So saying that the x squared is negative would be a bad thing. All right, lastly, between what two consecutive integers does the larger solution to this equation lie? Show this point on the graph. All right, so this is all about solving an equation graphically, right? And really what we're trying to interpret this as is find the x values where the y value is 0. Well, the y value is 0 on this really poorly drawn graph right here and really somewhere right around here. I just can't draw the graph very well. This is the larger of the two, and it falls between 1, 2, 3, 4, 5, 6, and 7. Between 6 and 7. All right. Well, don't put that calculator away. We're going to need it for the next exercise, so I'm going to even leave mine out, even though I may have made it quite small at this point. We'll make it larger in just a second. But pause the video now and write down anything you need to. All right, let's clear out that text. Oh, I almost snapped my fingers. That would have gotten rid of the calculator. Wouldn't want to do that. The magic snap. All right, let's take a look at exercise 4. Again, we got a little stereo going on with the graph. My apologies for that. That'll be fixed in the workbook. A sketch of the quadratic function y equals x squared minus 11x minus 26 is shown below, marked with its points at the intercepts and its turning point. Using tables or a graph on your calculator, determine the coordinates for each of the following points. All right. Over what interval is this function positive? All right. Well, what I'd like you to do is play around with this. Put it into your calculator, graph it, look at the table, etc., and see if you can come up with the coordinates for all 4 of those points. Pause the video now. All right, let's go through it. So we're gonna need our calculator again. We'll make it the right size for the screen, and let's hit y equals. Okay, I'm going to clear out the equation from the last problem, and I'm going to enter this one. So we've got x squared minus 11x minus 26. All right, once you got that equation in there, as always, look at it. Now we need subtraction signs, not negative signs. That would throw us off a lot, and wouldn't even give us an error this time. That'd be bad. All right, but it kind of looks good. Now I think I want to use the table. Who knows? I mean, if the points are integers, the table will work out well. I don't know exactly where to make it start, but let's pop into the table. Table setup, at least. Let's go into that. All right, now, based just on the picture, it looks like I've got an x-intercept that's negative and an x-intercept that's positive. So let's set our minimum to be -5. Okay, so not our minimum, but our table start value to be -5, and we'll go by ones to begin with at least. So now let's pop into our table. Okay, let's go into that. And let's start scrolling down. We're looking for those zeros. And we see the first one pretty quickly. See here, when x is equal to -2, y is equal to 0, that's got to be point A. So that's -2, 0. That's our first one. All right, let's find our other 0 real quick. So we might have to look for a little while here. I'm going to have to hit the down button for a while. All right. Now, by the way, as we're doing this, you can kind of be looking at things like turning points and whatnot. I'm not going to record them yet. And there's my other 0. Okay. So my other 0, what I can see here, right on the table is 13 in the x column, gives me 0 in the y column. So that's point B, 13, 0. What we're really doing here is just exploring how we can use the graphing calculator to investigate the behavior of a quadratic function. All right, hey, let's find the y-intercept. That's really easy, right? The y-intercept is going to be the output when x is 0. So let's go up in the table, get to x equals 0. Easy enough. The y-intercept is 0, -26. And when a parabola is written in standard form, there's your y-intercept. All right, now let's take a look at the turning point. This is going to be the most challenging one. Let's kind of go down in the table. And here's why it's going to be challenging, right? Notice that at x equals 5, we have a y value of -56. X equals 6, we have a y value of -56. That means that the turning point has to lie immediately between them, 5.5. Now, we need to have the y-coordinate at 5.5 as well. So there's a lot of different ways we could do that. We could just evaluate the function at 5.5, but since we're kind of in that table frame of mind, let's use the table. I'm going to pop back into table setup right now. And I'm going to make my table start at 5. But I'm going to make it go by half-unit increments. I know my turning point's at 5.5. I just don't know what the y-coordinate is. So I'm going to make it go by halves. Got that? Now let's go back into the table. And there right away, I can see the turning point, and I can tell it's at 5.5, -56.25. Okay. Last little piece, we don't really need our calculator for this, we have everything we need, says, at what interval is this function positive? At what interval is this function positive? All right, well, positive just means it's going to be above the x-axis. And it's above the x-axis here, right? So that's x values over here. And it's above the x-axis here, so x values out here. So it looks like it's positive whenever x is what? What was a? Less than -2, or when x is greater than 13. This is a great way to put it. I'm going to get rid of that little weirdness there because it almost looks like a negative. You can do it in interval notation. It would look like this: -∞ to -2, parentheses, not bracket. Then you use what's called the union symbol, union, 13 to infinity. By the way, we can't include the 13 or the -2. Here we don't have those equal signs, because at those locations, y is equal to 0. So it's not positive, it's neutral. All right. Pause the video now, write down anything you need to. All right, I'm going to get rid of the text. Now I think we can put our hard-working TI-84 Plus away. And now let's finish up this lesson, all right? So in today's lesson, we really just reviewed some real basics about quadratic functions, some terminology like turning points, axis of symmetry, zeros, y-intercepts. We also looked at the shape of a parabola and what controlled whether it was opened upwards or whether it opened downward. Okay, all of these are important as we move on. Now what we're going to be segueing to next is really a look at most of the algebra associated with quadratic expressions. So make sure that you really kind of look at the homework on quadratic functions before further lessons where we look at their algebra. I'd like to thank you for joining me for another Common Core Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.